Hello everyone, this is Bernard and today we are going to discuss very interesting topic on electrical harness design. And this topic is being requested by so many people in terms of understanding between the two major concepts that's called ECAD and MCAD. So why this ECAD and MCAD? So that is the topic which we are going to discuss on electrical harness design today. We all know that we are in a multidisciplinary environment where all the manufacturing products are taking a big transition in terms of electromechanical system. That means your components are getting connected to your antennas, sensors, all the stuff. Your electrical and mechanical has to be a seamless integration. Now when you talk about this, the electrical systems are interlinked with the physical design. That means any changes you do in ECAD has to be reflected on your MCAD. The major challenge for us is most of the manufacturing of harness design is that how integration happens, because ECAD use a different application and MCAD use a different application. So here the question rises is how we are going to collaborate between MCAD and ECAD. This is a big question and big concept which we need to understand first. And why this is very much important is any product you take it today, it's time to quick market is very much important, and product should be free, expensive in terms of quality issues. That means any changes in ECAD and MCAD is not taken care, and quality can be a major challenge. That means always there should be an associativity between an ECAD and MCAD. So this is the concept which we are going to work today. Harness being the nervous system of any of these smart connected products, so it's very much important that both get seamless integration. That means we need to understand how this ECAD and MCAD works functionally. So in this case, I'll just give an idea that ECAD is more into logical side. You can see it's more into logical side, whereas MCAD is more into the functional side. That means any changes you do in ECAD has to reflect on the functional packaging, that means mechanical packaging of your product design. So this is a very important factor which you need to consider while designing electrical harness. Now, if you see what is the major difference or what we do in logical and what we do in functional, let us deep dive into it. So logical is more into the wiring diagram first. Okay, where we have more of schematic information about wiring diagram. It's 2D, where we place the component in 2D. That is, placing of component plays an important role. Component plays an important role. What do you mean by component? It's all the terminals and the connectors and the pins, all the stuff. And in fact, the third one, we will be more focusing on the signal. Okay, this is the three major things what we do on the logical side. And what we do on the functional side. The functional side, predominantly, it could be any of the CAD applications. So that's the reason we use 3D CAD in space. That means we analyze the harness by installing in a 3D space. That means the digital markup plays an important role. Now when you do this, harness installation is very much important, which is once again derived by your inputs given from wiring diagram. That means always any changes happening on wiring diagram will reflect on your harness installation. So let us get into the details about what exactly the logical and the functional side is all about. What is logical and what is functional? As I told you, logical is more of schematics. That means we focus more on the wiring information. That means there is a terminal 1 and there is terminal 2. That means here we tell that the signal is flowing from terminal 1 to terminal 2. That's what we tell here. Signal is flowing from terminal 1 to terminal 2. So what are the things you will have? Here you will have the details about wire information. Okay, so you'll have wire information, and you will have the signal information, and followed with the terminals details. Okay, the terminals details, it's nothing but the connector, all the stuff. Whereas in functional, what we do is we just keep your T1. That means I will tell that in functional, any of the CAD package, I can call this T1 as connector 1, right? I'm just replacing by C1. And I have one more C2, that means the connector 2, where I'm going to just take this 2 as a factor and start routing. See, I'm just routing the bundle in 3D space. Okay, from the connector 1 to connector 2. That means from connector 1 to connector 2, I'm just routing this harness. Now if you deep dive, I'm just routing the harness, means I have to know the space. That means the length of the bundle. The length of the bundle means the entire bundle. So this is called bundle. Diameter 5B, bundle diameter. This bundle diameter is driven from the wire information. That means if you see, this is my bundle. See, I'm just going to draw the bundle diameter. So this is my bundle. How a bundle diameter B is defined? It is defined based on the number of wires inside the bundle. So I can have, say for example, 10 wires or 20 wires inside that. So that means based on your wire information, your bundle diameter information is taken into account. That means there should be a seamless integration between ECAD, that's what we call as ECAD, and so now if you just understand why this integration is important, because of the different data exchange what you will have it. So the file format, say for example, here we are talking more in terms of T1 and T2, where here we are talking about C1 and C2. That means any of the application MCAD, they may be having a terminology of C1 and C2, connector 1 and connector 2, whereas here you can have it as T1 and T2. So now how C1 and T1 is collaborated is so important for you to understand. That means there should be associativity between ECAD and MCAD by making the system to understand that T1 represents C1 and T2 represent C2. How it understands. So this is a big challenge for integration between ECAD and MCAD. So that means the naming convention of this application is different and the naming convention of this application is different. So you need to be very specific in terms of understanding this concept. So now you understand the importance of why ECAD and MCAD collaboration is so important. So this is so important that they need to work seamlessly in terms of data exchange and in terms of the file format and in terms of the entire product design. Typically, you define in MCAD the length. I will know what is the length from this particular point to this point. That means, say for example, I just defined as 150 mm. So the length of the harness is taken care in the MCAD. That means the length of the bundle is taken care. So that means MCAD is more into from to connectivity. For manufacturer, I will just give the flattened dimension or flattened geometry or nail board or a form board of inputs C1 to C2. The length of the bundle is 150 mm of diameter B. So it's a modular design, so I just manufacture and give to it. Development phase, there could be a change in product design. So the number of wires, as we told earlier, it is 10. Now it is reduced to 8. Automatically your bundle diameter should change. So I will tell as B minus 1, something like that. So that means your bundle diameter is seamlessly integrated with the wire information. So what is happening here is there should be always a bridge between an ECAD and MCAD. That's what we talk about this collaboration platform. Now you take Mentor Graphics, it takes care of it, or Zucam, this takes care of it, of making a bridge between ECAD. For example, MCAD could be a CATIA V5 or Unigraphics or Pro E, whatever it could be. So first understand that this is the concept of ECAD and MCAD. So always there is a seamless integration between in ECAD and MCAD, because if any changes happen on ECAD, it should reflect on your mechanical packaging. Hope you understand the concept of ECAD MCAD collaboration in this session. Thanks for watching this video from Bernard on A4 Sheet Learning. Thank you.